Hey everybody, Carl Fisher with the Tinkerverse. So we're going to do a little laser fundamentals today. It's not so much about software, it's about understanding how to find the best settings for your machine and really talk about why faster is not always faster. So let me explain what I'm talking about. When working with lasers, let's say we've got a 100 millimeter line. Not 100 meter, 100 millimeter line. And I want to engrave this. So I'm going to say, let's engrave this at 600 millimeters per second, because I got some new fancy laser and it says it can travel 600 millimeters per second. Great. So 600 millimeters per second. Now, let's look at a scenario here. Let's say we've got a nice house. Pardon my drawing. We've got a nice house, and at the end of that driveway there is a little mailbox. And I want to drive my car which is parked right here. I want to drive my car 60 miles an hour down to my mailbox, get my mail, and drive 60 miles an hour back up my driveway. So here's the trick. I want 60 miles per hour, or let's say 100 kilometers per hour for you folks overseas. And I'm asking my car to do that. So in order for my car to get up to 60 miles an hour, I actually need a whole bunch of time to accelerate and get up to speed, just like I'm merging onto the highway. And then once I get to the end, I need a whole bunch more time to decelerate and hit the brakes and stop. So I've done that. Pretend the house isn't here for a second. I've accelerated. I've gotten to 60 miles an hour. I hit the end of my driveway. Now I got to hurry up and slow down because I missed my mailbox. Let me U-turn. So I'm going to turn around and I'm going to go back and I'm going to accelerate and I'm going to go 60 miles an hour back. And guess what's going to happen? I'm going to crash into my house because I didn't slow down in time. That's very similar to how this works with lasers. A laser head needs a certain amount of time to accelerate and decelerate. So when you want your laser to go 600 millimeters per second, and that should be mm, you're going to say, I need this much runway to accelerate, get to 600 millimeters per second to do my engraving, and then I need this much runway to decelerate. Usually these are pretty close, acceleration and deceleration. I'm saying I need that much time so that in order for me to be at 600 millimeters per second at the start and the end of the burn, that's what I have to do. There is a problem with this, and a lot of you have seen this. So if your machine claims it can do all this speed, and maybe you're new to the engraving world, and the first thing you do is you drop your material in there, you put your design right up against the edge, and let's say your machine looks like this. You plug in those numbers and all of a sudden you get a warning that says, hey, I can't do this. You risk crashing the head of your machine or object out of bounds, something to that effect. And more often than not, it's going to be because of this. So just like your house, crash into the house going back, I'm going to crash into the side of the machine if I try to decelerate and I don't have enough room to accelerate to get up to speed. So the first thing we do is we move this line in. So we'll move the line in to here. And now I've given myself acceleration and deceleration room so that I don't crash on either side. And based on the quality of the machine, a higher quality machine is going to have a higher rate of acceleration. So this distance here is going to be more or less depending on really the quality and the precision and the capability of the mechanics of your laser. So that kind of talks about why you might see, and same on the other side. If you're too close to the right side, it may tell you that, hey, I'm going to crash over here. So if you're getting those warnings, pay attention to your speed as well as where you're placing the design within the machine boundaries. And most laser softwares will actually look at that and say, hey, you're too close, pay attention. So that's issue number one. Number two is let's talk about why it's not always fast to go fast. So we're going to take that same line, let's take a little bit better marker here, and we're going to take that same 100 millimeter line, and I'm going to run this at 3 different speeds. I'm going to run this at 100 millimeters per second, 300, and 600. Okay. Now, just like we saw before, I need a certain amount of acceleration time. So if I'm running 60 miles an hour, 100 kilometers per hour, 600 millimeters per second, I need a fairly significant runway on both sides to accelerate and decelerate. If I slow down to 300 millimeters per second, well, maybe now I only need this much time to accelerate and decelerate. If I run 100, I only need this much time. So you might be able to see where I'm going with this. When you look at your preview time, your job preview, so if you look in Lightburn, for example, you bring up your preview and you look at your engraving time, make sure you have rapid movement, traversal movements turned on, and look at your engrave time down below, and you're going to see rapid move time versus engraving time. This is your rapid move time. So all of those red lines that you see in your preview are all of this area where your laser head will be moving without doing engraving work. And that's to accommodate acceleration and deceleration. So as you look at this, I have to take this much time to accelerate, 600 millimeters per second, this much time to decelerate. 300 millimeters, well, I'm shortening the amount of time that I have to accelerate and decelerate, and I'm able to traverse this at 300 millimeters per second, and I'm even shorter still at 100. So your machine's going to have a sweet spot. Based on, again, the mechanics of your machine, how it performs, there will be a sweet spot in there where you'll get the fastest and best quality, frankly, best quality engraving in the shortest amount of time when you find the balance between your job, and this is going to vary from job to job. If I have a job that realistically is burning from one end of the machine to the other, I may want to eat that acceleration time so I can move faster across the machine. If I'm doing a smaller job, I may not want all that acceleration time, so I'm actually going to slow down my burn speed, and I'm going to find that sweet spot and play with your preview. Drop your engraving speed, and you're going to probably see that your engraving time, your total job time, goes down and gets completed faster. Play with that time until it stops getting faster. When you hit that point where it stops getting faster, you've kind of found that sweet spot. Now, there's obviously a little bit of wiggle room in there, but by and large, somewhere in the middle range of what your machine's capable of speed-wise is probably where you're going to land more often than not, unless you're doing small movements, small text, flood fills, stuff like that. Then it's actually probably going to be faster to do a slower speed because it'll allow it to quickly move back and forth without having to accelerate just to get to the burn. So play with those speeds, watch your preview times, watch your total job time. The goal is that you want to reduce your total traversal movement as much as possible without sacrificing the speed to do the burn. And then obviously you'll adjust your power accordingly, because as you slow down, you're going to want to pull that power back. Otherwise, you're going to be engraving much darker than you intend to. So that's the tip for today. That's why, oftentimes you're actually faster to go slower, and learning the fundamentals of what your machine is capable of, and the higher quality machines, again, you might be able to do this because that acceleration time may actually be down here on a really high-end industrial machine. So whereas, a $200 diode, it's probably going to be way out here. So play with that, play with your previews, play with those traversal movements and your speeds, and you'll find that sweet spot, and hopefully, give you a little bit better burn quality at the same time in your next job. So hopefully that helped you guys, and if you like this, make sure you're subscribed and hit that bell notification. I'm going to try and do some more quick hits that are laser fundamentals and software agnostic, so it's not going to be focused on a Lightburn, a Make It, an XCS, and just more along the idea of concepts of engraving to help you set up your next job. So thanks everybody, and see you in the next video.